Now we'll be looking at angles of elevation and depression, and this is one of the application of trig ratios that we studied. So let's first look at angle of elevation. So what is the angle of elevation? Like, this is the angle in which the line of sight makes with the horizontal level. And what do I mean by that? Imagine an observer looking at an object that is above and is looking at the object through this line of sight AC. The angle in which that line of sight makes with the horizontal level is referred to as an angle of elevation. A practical example would be, say you're standing on the ground and you observe an aeroplane flying, and please don't mind my diagram. So now you look at the aeroplane with this line of sight here. So the angle that your eyes or the line of sight makes with the horizontal level, this horizontal line drawn here, is called the angle of elevation. So now from the point in which your line of sight touch the object, if I draw a vertical line down, I can see that it makes a 90 degree with the horizontal line. And what does this form? This forms a right angle triangle. So based on the properties of right angle triangle, then we can use our knowledge of that to find the vertical height here and also the distance from the observer to the base of the object. So let's see how we apply this in practical terms. So in this example, we are told that from point P on a level ground. So let's try to sketch that out. So you have a level ground. This is level ground. I have a point P on the level ground. The angle of elevation of the top of a tree is 60 degrees. So now on this level ground, you also have a tree over there. This is the tree. And the angle of elevation of the top of the tree. So from this top of the tree to this line of sight, you have a straight line of sight to the top of the tree. We are told that the angle of elevation, the angle that the line of sight makes to the horizontal level is what? Is 60 degrees. I told that if the tree is 39 meter high, so now I told that the height of this tree is what? 39 meters. We're now told to how far is its base from P. So the base of this point over here, how far is this point over here to P? So we are told to find the distance from P to the base of the tree. So let me call that distance X. So now I can convert this into a right angle triangle. And what does that become? It's just like having a right angle triangle in which here is 90, here is 60 degrees. The height of the tree, which is this length over here, is 39. And I'm told to find the distance over here, which is what? Let me call that X. So now, if this is the angle 60 degree, I know that this will be my opposite and this will be my adjacent side. So what connects the adjacent and the opposite side of a right angle triangle? And we know that that is tan. So I can write that what? Tan theta is equals to opposite over adjacent. My knowledge of SOHCAHTOA. So tan 60 degree is equals to my opposite, in this case is 39, over my adjacent, which is what I'm looking for, and I've called X. So the value of X equals to 39 over tan 16. So I know that now X will be equals to 39 over, and with 60 is same thing as square root of 3. And if I convert that to decimal, I have 1.732, and 39 over 1.732 gives me 22.52 meters. So the distance from P to the base of the tree, which is X, is equals to 22.52 meters. Now let's look at another example. In this example, we are told that a student stands 20 meters away from the foot of a tree and observes that the angle of elevation of the top of the tree measured from a table 1.5 meters above the ground is 34 degrees. Calculate the height of the tree to the nearest meter. This is a typo. This is supposed to be D. So now, let's try to sketch out our problem. You have a student standing 20 meters away. So this is your student over here. And he's standing 20 meters away. So he's standing 20 meters away from the foot of a tree. So the distance is 20 meters. And there's a tree over here. This is the tree over here. Now I told that and observe that the angle of elevation of the top of the tree measured from a table 1.5 meter above the ground. So beside the student there is a table there, and that table, the height of the table from the ground is what? Is 1.5 meters. Now I told that from that table that the angle of elevation measured to the top of a tree is 34 degrees. So if this top of the tree, then from the top of the table to that point over there, the angle of elevation, and we say that the angle of elevation is the angle that is made with line of sight with the horizontal line. So I need to draw out an horizontal line, that the angle of elevation is what? 34 degrees. Now I'm told to find the height of the tree. So I can sketch this out. So I know that the distance from the base of the student to the tree is same thing as the distance from the table to the tree. So here also be what? 20 meters. And since the height of the table is 1.5 meters, I know that the height from the base of the tree to the corresponding height of the table will also be what? 1.5 meters. So what I'm left with now is to find the height from the top of the tree to the point where it aligns with the table. Then I will add it to 1.5 to get the height of the tree. So I can bring out this right angle triangle, and what does that become? So I have a right angle triangle in which the angle here is 34 degrees, the base here is 20, and I'm looking for the height. So I'll call that x. So I know that this is my opposite and this is my adjacent. So to get the height, I know that tan connects the opposite and the adjacent side. So tan theta is equals to opposite over adjacent. So I can write that tan 34 is equals to opposite, in this case will be x, over, and my adjacent is what? 20. So x, which is the opposite in this case now, will be equals to 20 times tan 34. And what does that become? That becomes x is equals to 20 times tan 34 is 0.6745, and that becomes 13.49. So now I have 13.49 meters. So the height from this point over here to this point over here is what? 13.49. So the height here is what? 13.49. But the question asks us to calculate the height of the tree. So now the height of the tree, we know that it's because of this height over here from here to here plus from here to here. And since the height of the table is 1.5, we know that the distance from here to that portion over here is what? 1.5. So the height of the tree will be equals to what? 13.49 plus 1.5. And what would that give us? That will give us 14.99. Now since the question asks us to find the height of the tree to the nearest meter, we have to convert it to the nearest whole number. And what would that be? That would be 15 meters. So the height of the tree is 15 meters. Now let's look at angle of depression. So here I'm going to use this example. So this is a lighthouse here, and this is a canoe out in sea. So what is the outlight used for? So when ships and other means of transportation in the sea and wide in the ocean, then they use the lighthouse to locate where the shorelands are. So when a sailor in the sea sees a lighthouse, he knows that he has to move towards that direction in order to come to the shorelines. So that is what the lighthouse is for. So now when a sailor is looking at a lighthouse, he's looking at it through the angle of elevation, because looking up to the upper portion of the lighthouse where there is a lamp that produces light. However, if there is a person staying at the top of the lighthouse and is looking down at a sailor, or in this example at a man inside this canoe, the angle between his lighthouse sight and the horizontal line drawn from that point, leaves the horizontal line drawn from the point, is called what? The angle of depression. The angle of depression. So another practical example would be if we live in a 3-story building, for example. So let's assume we live in a 3-story building. So this is the first 1, 2, 3, and you're standing here, and now there's someone outside on the floor playing, and you're looking at the person. So as you can see, this is your line of sight towards the person. So the angle that line of sight makes towards the horizontal line join from the point of your eyes is called what? The angle of depression. Now there's something interesting to note, and what is that? That this angle over here, since this horizontal line is parallel to this line at the base, that this angle over here is the same thing as this angle over here, which I'll call x. So this angle over here, if I draw another horizontal line here, is equal to the angle over here, and we'll call that alternate angle. And if you recap, if you have two horizontal lines, I have a line that pass through, you know that this angle over here theta is equal to the angle over here theta, and we'll call that property alternate angles. So these are what? Alternate angles. So that concept will come in really handy when we are trying to solve questions that have to do with angle of depression. Now I'm going to be looking at an example, and in this example we are told that a point T is on the same horizontal level as the foot of a tower. So what does that mean? So let me first draw the horizontal level. So we have an horizontal level, then we have a tower. So this is a tower. I thought that a point T is on the same horizontal level at the point of the tower. So let me call that point T. If the distance of the foot of the tower is, if the distance of T from the foot of the tower is 80 meters, so if the distance from the point T to the foot of the tower over here is what? 80 meters. So the distance between those 2 points is 80 meters. And the height of the tower is 60 meters. And the height of the tower over here is what? 60 meters. Find the angle of depression. Find the angle of depression of T from the top of the tower. So if there's someone standing at the top of this tower now and is looking down at point T, I'm told to find the angle of depression. So from that top of the tower, I'm just going to draw a line towards the point T. And we're told that the angle of depression is the angle that the line of sight makes what? With the horizontal axis. So the angle of depression in this case will be this point over here, which is what? Theta. So based on our idea of alternate angle, we know that if this angle here is theta and this horizontal line is parallel to the foot level, we know that this angle also here this angle here will also be what? Theta. So we can bring out this triangle and have a right angle triangle. So what we have is a right angle triangle that looks pretty much like this, in which we are trying to find this angle here theta. And we are told that the distance of the base of the tower to point T is 80, and we are told that the height of the tower is 60. So we are trying to find the value of theta. So this is the opposite side, and this is the adjacent side of the triangle. So what connects the opposite and the adjacent? I know that is our tan. So I can write that tan theta is equal to the opposite over the adjacent. In this case, I know that my tan theta will be equal to the opposite is what? 60, and the adjacent is 80, and that will be what? 0.75. So tan theta is equal to 0.75. So theta will be equal to what? Arctan of what? 0.75. And when you punch this into your calculator, you get theta to be equal to what? 36.87 degrees. And since the question asks us to give an answer to the nearest degree, we convert it to the nearest number, and that becomes 37 degrees. So the angle here, which is same as this angle here, is equal to what? 37 degrees. And since it's an alternate angle with this angle of depression over here, I know that this angle here theta is equal to 37 degrees, and that is the what? Angle of depression. So the angle of depression of T from the top of the tower is what? Is 37 degrees. So what I want you to do now is to go through the textbook and try to solve some more questions that have to do with angle of depression and elevation. That will be all for now.